Hello everyone, today we are going to introduce our online gaming, Game With. And today's presentation will be divided into 4 parts, including inspiration, demonstration, structure, and improvement. So let's take a look at our inspiration part at first. Our game With is inspired by Kahoot, a free game-based platform that makes it fun to learn. We just mimic the format of Kahoot and create our own game. Game With is a game where players can compete at speed of judgment and reaction with each other. It is an online game which allows multiple players to play at the same time. User interaction is a main part of our design, which will be introduced in the following sections. We follow the design language of Google Material U to make our GUI. Our arrangement is based on the chat system structure, but we rewrite all the codes by ourselves. The game questions are the color names, but the color of the button doesn't match with the word. Players should choose the same words as the questions. And the quickest is the winner. So basically, the game is to test your reaction time. So now let's take a look at our game demo.
Now let me show you how the game works. First, let's start the server. And then we can run the file called game cmdr player. And the GUI will be shown. We can enter our player name here and either create a new room or join a room. We click new room here to create. And we can enter the new room name. And I just enter it R. We can go back to the home page, but now we are going to continue. And here it shows the room name, the player in the room, and a start game button. If we click that, the game will start. But now the game won't start because it should be at least 2 people in a room to start the game. And now let's enter a new person here. Here, the name should not be the same as the first person. If I enter the same name and click either button, it will show that the name has been registered. So let's enter another and click join room. Here, only the room that has been registered can be read. So if I enter a room that had not been registered, then it will tell the player that no such room. And let us enter another room that has been created. Here we can see that the room member have been updated in both GUIs, and we can click the start game. Here's the question. It is a color name, and all the choices are 4 colors. The word and the color of the button doesn't match. So the player should choose the word that is the same as the question, but not the button color that is the same as the word. So here, this is the right choice. And others like this is the wrong choice. And if every player has made the choice, they will enter the billboard. The billboard page only lasts for 5 seconds, but I want to stay here for a little bit longer. This shows the current top player and the score of the current top player and the player's current score. And here is the round number. If the countdown is going to be 1, and we'll skip to the next page. And here it is the player ranking. We can see a beautiful animation. And the top player and the second place, the third place will be shown on this podium. If there are only 2 players, the third place will be a blank. And if there are over 3 players, only the first 3 will be shown in this podium. After the demonstration of our game, let me walk you through the structure. It is really similar to the chat system structure. First, we get a file called game utilities. It contains functions that handle the sending and receiving messages and also generate the game question. Another file is called game room. This is a class, and there's a dictionary called self-members. The key is the player name, and the value is the player's score. If a player doesn't enter room, his score will be -1. And if he enters the room, his score will be 0. if the player makes the right choice and the score will +1. In this file, there are also functions to add and delete players, add score to the player, join or create rooms, get all players in the room, and get other players in the room except the player himself. Then the main part of our system is the GUI custom tkinter and the game server. We'll talk about that later. And we also get two files called game player class and the game CMDR player. These two are similar to that in the chat system demo code, and they are used to run the GUI file. We actually built the player state machine at first, but when developing the code, we found out we didn't make use of that, so we just separate that.
So now let's take a look at the GUI assets file. We import the custom key linker to create buttons, labels, and entries that we use throughout the design. The main reason why we use custom tkinter instead of tkinter is that custom tkinter has an attribute called corner radius. This attribute can help us create rounded corners to get a modern look of our GUI. The asset we create looks like that. The code on the left-hand side is to locate our background images, and the code on the right-hand side is the initialization of our class. The color palette we use here follows the design language of Google Material U. This is the code of how we create a new game page. Basically, the logic is to create a canvas and fill in with a background image. Then we create frame to locate everything easier. The buttons and labels we use here is from the GUI assets file, as we have mentioned. We pack entries and buttons into the frame. Then a page is done. This is the animation function that we use in the game. The key point is the after function of tkinter. It can refresh the position of components after a certain period of time. This function is used recursively. We use the same logic to create the countdown at the game rule page.
Here I'm going to show you how the GUI communicates with the server. Since user interactions are mostly clicking buttons, we thought it's not necessary to use a state machine when developing the code, but it turns out that we should make improvements here. Let us first take a look at the game server. The server handles actions of registering the player name, room name, generating questions, and handling player ranking. It records the winner of every round of gameplay. We met our first difficulty when making the parent page. We want to achieve that whenever a person enters the room, there will be a new label shown in the GUI. So there are two loops, the loop for continuously receiving messages and the main loop of tkinter. At first, we simply wrote the code for receiving messages in the function for creating the GUI. However, the GUI will be stuck at receiving the message. So if no message is received, then the following code to draw the GUI will not be executed. Then we try to use thread. Our first attempt was to open a thread in the function that draws the parent page GUI so that we can receive the message while running the GUI. As long as the message is received, it will call the parent page function again to update the room member list. However, it didn't work because whenever the GUI function is called, a new thread will be created and there will be a lot of threads created. So we separated the code that opens the thread from parent page GUI. The thread for updating the message will be opened before executing the parent page function. In the threading, whenever the message for updating room member is received, the GUI function will be called. But the bug is still not fixed because we found out that although tkinter can work in two threads, we cannot modify the tkinter in one thread from another thread. A simple solution is to use top level in tkinter, but the main window cannot be withdrawn. And also when clicking the game start button, the program will crash. Finally, we came up with a relatively perfect solution. We first open a thread and execute the get response function to receive the message from the server continuously. Then we write another function outside of the parent page function called update member. In this function, it only updates the element in the frame for showing room members. This will be executed by the after function in tkinter, and then loop itself recursively. When entering new recursion, the code will check if a new message has been received in another thread. If received, it will update the frame that contains labels for the room members. It took us almost 3 days to find out this solution. We used the same logic to write the game playing page. During the game, if the player presses the correct button, then the border will turn green, and if he presses the wrong button, the border will turn red. This is done by executing the change button color function as is shown here. When the button is clicked, then this function will be called. This is divided into 2 parts. In the first part, the label is either true or false. It tells the server that the choice is made. Then it enters the second part to get response. The last player in the room to answer the question will receive a unique message. He will be able to send a start game message if the round number is less than 5. After this is sent, other players will receive the message telling them to enter the billboard page. In this way, all players can either enter the billboard page or the ranking page at almost the same time.
Our code works, but not that perfect. We have listed some parts to be improved. First, we should make good use of the state machines. It can help us control the GUI and server more conveniently. Second, we want to add a function to allow players return back to the home page and restart the game. Third, we want to let players set questions by themselves. And fourth, we want to create responsive layers that fit all window sizes. And fifth, we want to improve our code efficiencies. Thank you for listening.